Hello 12th class students. Today we will continue our previous chapter, that is P block element, and in this video we will study about the nitrogen's important compounds that are widely used in our day-to-day life. Students, nitrogen forms so many compounds that are widely used in our day-to-day life, but we will study about the two most important compounds of the nitrogen, that is ammonia and nitric acid. Ammonia, that is NH3, and nitric acid is HNO3. Along with these two nitrogen compounds, we will also study about the oxides of the nitrogen, that is NO2 nitrous oxide and NO, that is nitric oxide. So let's begin with the nitrogen compound ammonia. Ammonia, students, is widely used in our day-to-day life in the form of refrigerating gas. Ammonia also produced in nature by the decomposition or reduction of the organic compounds by the bacteria. How we can prepare ammonia in our industrial scale as well as in laboratory? Let's see. So we will see the preparation method of ammonia. Preparation of ammonia. First of all, if we see the preparation of ammonia in industries, then we can prepare it easily by heating the ammonium salt like ammonium sulfate, ammonium phosphates, etc. Let's see the reaction, how the reaction takes place when we heat the ammonium sulfate salt. The chemical formula of ammonium sulfate is NH4 whole twice SO4. Whenever, students, we heat this ammonium sulfate, then ammonia and ammonium hydrogen sulfate is formed. Ammonia, that is NH3, and ammonium sulfate, that is NH4 H.S.SCHOOL, ammonium hydrogen sulfate. This is the product. Now if we expand this reaction, then let's understand how this reaction takes place. NH4 and NH4 both are combining with SO4. Whenever we heat this, then one hydrogen from this ammonium ion get attached with sulfur and NH3 remains here. So NH3 plus this NH4 plus this one hydrogen which was removed from the NH4 hydrogen, and this is this SO4. So in this way, students, the ammonia and ammonium hydrogen sulfate is formed. Let's see another example, that how the ammonia can be prepared with the ammonium phosphate. The chemical formula of ammonium phosphate is just nearly same. Here this ammonium will be 3 and here will be PO4. In this reaction also, students, we have to heat the ammonium phosphate, and in this reaction we will get NH3 ammonia, water along with HPO3. The name of the HPO3 is metaphosphoric acid. It is known as metaphosphoric acid. Now see, balance this reaction, students. Then two ammonia are prepared here. So these are the two methods by which we can prepare ammonia with the help of ammonium salts. Now this is the industrial scale methods, but if you want to prepare the ammonia in laboratories, then how we can do this? In order to prepare the ammonia in laboratories, we can easily get reacts of the ammonium salts with alkalis by reacting ammonium salt just like ammonium chloride with alkalis. We can prepare ammonia in laboratories. Let's understand it with the reactions. The second point is laboratory preparation of ammonia. In this case, students, we have to get react the ammonium chloride or salt of the ammonia with alkalis like calcium hydroxide. So we can easily get reacted CaOH whole twice, that is calcium hydroxide. When we heat them together, then we get ammonia NH3 plus water molecules, that is H2O plus calcium chloride, that is CaCl2. Now if we balance this reaction, then 2 ammonium chloride, 1 calcium hydroxide, then 2 molecules of the ammonia and 2 molecules of the water are prepared here. So you can see, students, here that whenever ammonium chloride, that is NH4Cl, reacts with any alkali, here we have taken calcium hydroxide CaOH whole twice. Whenever they heated together, then they form ammonia along with the preparation of water molecules and salt of the calcium, that is calcium chloride. In this way, we can easily prepare ammonia in laboratories. Now, the next preparation method is very simple type of preparation method of ammonia, but it is most important method also, because so many times it is asked in examination, or the question based on this method are asked in examination nearly every year. The name of the method is Haber's process. So let's understand Haber's process for manufacturing of ammonia. If you see the reaction of the Haber's process, then it is very simple type of the reaction and nothing can be simpler than that. In this, nitrogen combines with hydrogen to form ammonia. Now, it is the most simple type of the reaction. It is actually reversible reaction that we can easily break down the ammonia in order to get the hydrogen and nitrogen. If we balance this reaction, then 2 nitrogen, 3 to the 6 hydrogen, 6 hydrogen. But here we have to create a high pressure and high temperature along with the presence of the catalyst. Here we have to provide 500 degrees Celsius temperature along with 200 Pascal of pressure, or 200 atmospheric pressure we can say, along with the presence of catalyst. And which are the substances or elements that are used as catalyst? So here the powder of molybdenum MO plus powder of iron Fe are used as catalyst. Let's see the setup for the Haber's process, that what is the diagram for Haber's process. So students, here you can see the setup for Haber process. that how the nitrogen and hydrogen get combined together to form the ammonia. Here in this setup, students, we have two pipes through which the inlet of nitrogen and hydrogen in the ratio 1:3 is done. 1:3 because when nitrogen combines with hydrogen to form the ammonia, then their ratio is 1:3. So the thrice quantity of the hydrogen is required in order to make one molecule of the ammonia. Whenever we inlet the nitrogen and hydrogen, then here with the help of a pump, high pressure is created. We have seen that 200 atmospheric pressure is required. So here this pump acts as compressor. It will compress the hydrogen and nitrogen, and this hydrogen and nitrogen then enter in a chamber where the reaction takes place. Here in this chamber, high pressure along with the presence of catalyst which is required for combination reaction of the nitrogen and hydrogen. So here we can see that either molybdenum and iron is present, and the reaction that is N2 plus H2 gives to NH3, 3 hydrogen and 2 molecules of ammonia are produced here along with the high pressure near about 500 and temperature near about 500 degrees Celsius is produced. So students, at this much high temperature, maximum amount of the nitrogen and hydrogen get combined to form the ammonia, but some nitrogen and hydrogen remains unreacted at this temperature also. So ammonia along with the nitrogen and hydrogen are run out from this pipe. But remember, this mixture of the ammonia and hydrogen and nitrogen is at very high temperature, near about 500 degrees Celsius. So when it rushes into another chamber through this pipe, then in order to cool it down, we use the water stream. The water stream in this chamber enters from here. The cold water get entered from this pipe and removed or ejaculated from the upper pipe. And ammonia and the mixture of nitrogen and hydrogen runs in this pipe inside the chamber in the form of coil, so that its surface area increases and it cool down easily. Now, when the ammonia cool down, then it gets converted into liquid. So that liquid ammonia is taken out from this tank. Here it is our liquid ammonia. Because at high temperature the ammonia remains in the gaseous form, but whenever its temperature cool down, then it converted into liquid. But the nitrogen and hydrogen which were present in the form of the gas does not get converted into liquid. And again, that nitrogen and hydrogen N2 plus H2 come out and exhale with the help of this pump, and then again unused nitrogen and hydrogen with the help of this pipe again come in this chamber, and again we try to get react in the form of ammonia. So this whole process is called Haber process. In this process, high temperature near about 500 degrees Celsius and high pressure near about 200 atmosphere is required. At this high temperature and pressure, ammonia and nitrogen and hydrogen get combined to form the ammonia. Molybdenum and iron power is used as catalyst, because the presence of catalyst is very important. So this is all about the Haber's process. Now students, if we talk about the property of the ammonia, this was all about the preparation method of ammonia. And now the properties of ammonia. If we talk about the properties of any chemical compound, then we divide both the properties into two forms. One is physical property and other is chemical property. Now, the physical property of ammonia is that it is colorless gas. It has no color, but it has pungent smell that we can easily identify it with the help of its smell. Second thing. Third thing, it has lacrimative effect. Lacrimative, that means it produces tear. Whenever it comes in contact with our eyes, it produces tearing effect. The fourth property or fourth physical property is that it is readily soluble in water. And if you talk about the solubility coefficient of the ammonia, then near about 1300 part can be dissolved in 1 part of water at 0 degrees Celsius. In terms of solubility, the temperature is always mentioned. So, you can see that how highly soluble is this gas in water, and it is readily it can dissolve in water. So, these are the physical properties of the ammonia. Now, the most important, that is chemical properties of the ammonia. The first property is when ammonia passes through the electrical spark, then it breaks down into its constituent gases that are hydrogen and nitrogen. First, when ammonia NH3 passes through electrical spark, then Na2 plus H2 are formed, balancing this equation 2, 3. So this is the first chemical property. Second chemical property is that the ammonia gas does not get burned itself, neither it helps in burning, but it burns in the presence of oxygen to produce nitrogen and water vapor. Let's see how the reaction takes place. NH3 combined with oxygen to produce nitrogen gas along with the water molecule. If you balance this reaction, then 4 hydrogen, 4 NH3 ammonia, then 2 nitrogen. So the ammonia gets combined with oxygen and it burns in the form of yellow flame to give nitrogen and water vapor. These are the two properties. Next, third property. In the same reaction, students, if we add catalyst platinum and make this reaction feasible at very high temperature, that is near about 800 degrees Celsius, then product gets changed. See the reaction. When this ammonia reacts with oxygen, the same reaction, but the physical condition gets changed. Here, the platinum acts as catalyst and the temperature near about 800 degrees Celsius. Then water H2O plus nitric oxide, that is NO, are formed. Let's balance this reaction. 4 nitrogen, 5 oxygen, 5 to the 10 oxygen, then 6 molecules of the water and 4 molecules of the nitric oxide are produced. Both the reactions are same, reactants are same, but just due course of the change in the conditions, the temperature as well as the presence of the catalyst is changed, then the product entirely get changed. In the first reaction, nitrogen and water vapor were formed, but in the second reaction, water vapor along with the formation of the nitric oxide is done. Next property, students, when ammonia is passed over for sodium, then it produces sodamide along with the formation of the hydrogen gas. Let's see the reaction. The fifth property is when ammonia passes over sodium at a temperature near about 300 degrees Celsius, then sodamide, the formula of sodamide is NaNH2. Sodamide along with the formation of one extra hydrogen molecule is done. Let's balance this reaction. Then nitrogen, one nitrogen, sodium, one sodium, hydrogen, 3, then 2 to the 4. So 2 nitrogen, 3 to the 6 hydrogen, 2 to the 4, 5, 6, 2 sodium. So here you can see, students, that when ammonia reacts with sodium at very high temperature, then sodamide NaNH2 along with the formation of the one molecule of the hydrogen takes place. Another most important reaction or most important property of the ammonia is that ammonia reacts or get dissolved in water to form ammonium hydroxide. Ammonium hydroxide is a strong base. Let's see how the reaction takes place. The sixth one is reaction of the ammonia with water. So it is also very simple type of the reaction, that is NH3 plus H2O. Whenever they dissolve, they give NH3 NH. It is H4OH because one hydrogen from this water molecule also combined with this hydrogen NH4OH, that is ammonium hydroxide. Ammonium hydroxide is a strong base which is bitter in taste, and it is base because in a reaction it always produces OH ion. When we see its breakdown, then it always breaks down into NH4OH, always give NH4 plus OH minus. So it is a base. So student, this is all about the chemical properties of the ammonia. Now let's understand the uses of ammonia in our day-to-day life. First of all, the ammonia used in cold storage or refrigerators in order to cool down the temperature of the objects inside them. Second thing, the salts of the ammonia are used in medicines. Second uses. Third uses, ammonia is used in dyes for the strong colors that are used for dyeing the hairs, dyeing the clothes and different things. Fourth use of the ammonia is that it is used in manufacturing of the urea, which is used as fertilizer in agriculture. Next important use of the ammonia is that it used in the processing of the silk which is naturally obtained from the silkworm. Then ammonia is used in order to process it and or for the formation of the artificial silicons. So these are the some important uses of the ammonia in our day-to-day life. That's all in this video, students. In the next video we will continue the nitric acid.